previously learned that the pH value can be calculated by this log function, pH equal to negative log hydrogen ion molarity. Then you can actually write down also its inverse function, that H plus molarity is equals to 10 to the power negative pH value, so that you can easily interconvert between the pH value and then the molarity of hydrogen ion. And be reminded that what you put into this log function is the concentration of hydrogen ion in terms of molarity, but not other types of concentration, say for example in gram per dm per or gram per cm per, is the first thing. And then the second thing is that this molarity is with respect to hydrogen ion, but not the acid itself or the anion. Is it clear? So when you put the number into the data, say for example in question 1, pH of 1 mHCl, and in 1 mHCl the concentration of H plus is also 1 m. So we directly put this into negative log 1. And for any log function, log 1 equal to 0. So the pH value equal to 0. Oh, and then similarly for 2 mHCl, correct to 3 significant figures. And be reminded that for pH value it bears no unit. More difficult example is about sulfuric acid. And in this case it's because in one H2SO4 molecule, because it's dibasic, so that there will be 2 hydrogen ion per molecule that can be ionized. It means that the hydrogen ion concentration should be a double by comparing with that of H2SO4. So when you are putting into the equation, you have to multiply the concentration in molarity of sulfuric acid by 2. So the answer is negative log 0.288. That is 0.541. And similarly, for this phosphoric acid, it is a tribasic acid, so you have to multiply its concentration in molarity by 3 first in order to calculate the correct answer. So it should be equal to 0.332 negative. Is it clear of how can you do this kind of calculation? And then for question 2, you have to apply the inverse function of pH equal to negative log H plus molarity. So if you put into this function, then just by clicking the calculator you can got the answer. Is it okay? Oh, then for the second part is a little bit difficult. It's because first of all you have to find out the H plus concentration in molarity by again this formula. And then what's more is that you are finding H plus molarity in the above relationship. Obviously it asks you to write down the molarity of the acid, and because the molarity of acid, it should be only half of the hydrogen ion concentration, because it's a dibasic acid for sulfuric acid. So after your calculation, you have to divide the molarity of hydrogen by 2 is the mole ratio between sulfuric acid and H plus. You can got the answer equals to 0.294 m, and that's it. Oh, and try to link the two concepts together when you are mixing several acid solution together and then calculate the pH value. And the shortcut is that on your rough worksheet you can write down it in this way. However, don't write it in your real answer, but it can help you to think. The first term is that it actually helps you to find the total number of moles of hydrogen ion first. And then you can use the first acid, hydrochloric acid, M times volume in dm cube, and then times the number of hydrogen ion, the mole ratio in HCl, that is 1, and then plus the molarity of H2SO4 times its volume in dm cube, 20 divided by 1000, and then followed by the basicity of this acid, because 1 mole of H2SO4 can give you 2 moles of H+, so that we have to add back this mole ratio 2. And then the total volume of solution, it will just be the sum of the 10 ml and 20 ml divided by 1000. So by these two terms, you just need to do the number of moles divided by the volume in dm cube, and then you can got the H+ molarity first. And for the total number of moles of H+ is equal to 0.138, and then divided by the volume in dm cube, and that is 4.6. And finally, is that what asked in the question, you have to find out the pH value, so that the final step is that for pH value E equal to negative log, and then H+ concentration, and H+ concentration equals to 4.6 now. So after you use the calculator, then you got the answer already. Oh, and this all about the pH value and the H+ molarity and the relationship between them. Oh, and finally, is commonly appear in DSC is that you have to link those number of moles, molarity, volume, and mass, that kind of things together, and that's all about mole calculation. And you have learned that before already, the mole calculation, how can you manipulate those data. However, you have one more relationship this time, is that number of moles equal to mv. Once you convert all the data into number of moles, then you can just trick the question as before. You see the idea. So normally, we will have to write down the equation like this. Mg reacting with HCl to give a metal salt, and then hydrogen, and then write down all the data below. So for example, in this case, Mg, it is in excess, so we do not need to check which species is limiting. Obviously, HCl is limiting. And now you have two data, 25 cm cube, and then is 2m. And then what you have to find out is the number of moles, and therefore the mass of hydrogen formed. Is it okay? Then follow the same procedure. First step must be find out the number of moles of a known species, and you have no choice. What you know, all the information is one species, HCl. So the first step, number of moles of HCl equal to mv. And then the second thing is that, just like you trick the mole calculation before, we have to use the mole ratio. And now reacting 2 HCl will give you 1 H2. So the mole ratio between them should be this ratio, 2 to 1. And then for the number of moles of H2, we start from this number of moles of HCl, and then just half of it will be formed. And finally, you got the number of moles of hydrogen, then you just need to multiply it by the molar mass of hydrogen. Can you see the whole idea? Actually, nothing special. What you need to learn is that you have to know number of moles equal to mv, and that's it. And other skills you learn it long before when you start learning about mole calculation. Oh, and how about in question 2? Two of the species, they are in forms of the molarity and volume, and what you have to find out is the molarity of sulfuric acid. And similarly, write down the chemical equation, and NaOH reacting with H2SO4 to become the metal salt, because it's a neutralization process. And then after that, make it as your habit that write down all the information below the equation. Now you have 25 ml 0.4 m NaOH, and then you have 41.8 ml of H2SO4, and what you have to find out is the molarity term. So you already know that which species you should start with, and obviously it's sodium hydroxide in this case. So number of moles of NaOH, and then use MV, M 0.4, volume in dm cube, 25 divided by 1000, and then just use the mole ratio between them to find out the number of moles of H2SO4. And for 2 NaOH, it will react with 1 H2SO4, so that the ratio in between is 2 to 1. It means that when you are finding out the number of moles of H2SO4, you have to times 0.5, that is half of that of NaOH is listed. And then finally, for this term, it will be equal to mv, and m is your target, so that leave it. And then for the volume is given as 41.8. Is it okay? So m, the molarity of H2SO4, equals to 0.4 times 25 divided by 1000 times 0.5, and then this whole term we have to divide it by the volume of H2SO4 in dm cube, so you can get the answer, which is equal to 0.120 m. Oh, is it clear of how to do? So in this chapter, you actually learn not so many things, just one more relationship, that number of moles equals to mv. And I like to present it in this way because we can link all the number of moles equation together. Number of moles equal to number of particles divided by L, and equal to mass divided by molar mass, and equal to mv. But be reminded that for each of this relationship there is a limitation. For mass over molar mass, it is applied on a pure substance only. If the sample it is impure or is a mixture, then we cannot use mass divided by molar mass. And then for mv is used in a solution, which is a mixture. And the concept is that the molarity, that is the concentration, and then when it multiplied by the volume in dm cube, we can find out the number of moles of it. I mean number of moles of the solid. And then for the V should be the volume of the solution. Oh, and then secondly, refer to the equation what factors will affect the molarity, and molarity equals to number of moles of solid divided by volume of solution in dm cube. And these are the two factors affecting molarity. The more the number of moles of solids, then the higher the molarity, or the smaller the volume of the final solution, the higher the molarity. And that's it. Just think of the equation, then you can draw this conclusion already. And then finally is that if it is not specified, then in chemistry we usually use molarity. And this is because we can compare the number of substance in a certain volume of solution easier. If we use the concentration in gram per cm cube, gram per dm cube, maybe the number of moles of a species is smaller, but that species has a much higher molar mass, then the concentration shown will be higher. So molarity is better for us to use. And that's it for molarity calculation. And in the following section you will learn a concept called volumetric analysis, and in that process you have to be familiar with molarity calculation.